Welcome back. In this lecture, we will mention two modes of operating the battery within the hybrid electric vehicle and also provide the different kinds of hybrid electric vehicle configurations that are possible. All these things are associated with different trade-off. We will mention some of them. So in a charge sustaining mode, the main feature to be noticed is that the SOC of the battery does not vary much. So the battery in some phases gets discharged, so it assists in providing power. When the state of charge decreases, let's say from 0.7 to particular value, then the charging kicks in. Okay, so the SOC increases. So the SOC can increase beyond the average SOC of the battery to in this region. But the main thing to notice is that the energy that can be supplied from a battery is relatively less because you're not completely discharging the battery. So the SOC window, operational SOC window is rather narrow. So you've seen such a feature in a previous lecture when we looked at SLI batteries, the starting, lighting, ignition batteries, whether in which case you are only discharging the battery to 3%, right? So 97% is retained because you want to improve the life cycle of the battery. The number of times SLI batteries are operated is a lot. You start the car many times. Therefore, you do not want to be discharging the battery to a great extent. Likewise, even within a hybrid vehicle, you may operate in a charge sustaining mode. The disadvantage with this is that the size of the battery is much larger. But the advantage is that the number of cycle to which the life cycle is greater, the number of cycle to which the battery can be operated is also greater. So those are the trade-offs associated with the charge sustaining mode. As opposed to this, you have this charge depleting mode, wherein the SOC of the battery may significantly decrease. You start at 0.9 and it comes down to around 0.35. When the transition occurs, you sustain the battery at this SOC. Okay. So this is the charge depleting mode. This is the charge sustaining mode. So what is the trade-off here? Here, the energy you can obtain, energy capacity you can obtain from a particular battery is much more because you are able to get a lot more energy because of decrease in SOC. But again, the disadvantage is the number of cycles you may be able to operate might be lesser. You may have to change the battery within um, a lesser time. So this is all about trade-off, depends upon the chemistry, cost of batteries, the size of the vehicle, and corresponding sizing of the batteries. But these are two broad modes of operating, charge sustaining mode and the charge depleting mode. There is also another jargon called the degree of hybridization. So that is provided by this formula. The power you may obtain from a battery divided by the engine power plus the battery power. So as you would have expected, the degree of hybridization should not be very low or very high. If it is very low, let's say below, let's say 6%, then the point of integration is lost, right? You've added to the complexity of the system. Many new components have been have been integrated into the vehicle. And if you operate with a low degree of hybridization, All this complexity is unnecessary. It adds to the cost and complexity without really providing benefits of hybrid vehicle. Likewise, if you increase the degree of hybridization, let's say beyond 60%, that is also not that advantageous because the size of the battery increases. Along with that, the mass of the battery also increases. So many a times you are driving around the battery rather than the people inside the car. So you want to be operating in an effective degree of hybridization. Again, this depends upon the nature of vehicle you're operating. It depends on whether it's a small car or an SUV and so on, and the nature of battery chemistry that is being utilized. To summarize, we are presenting few other um, uh, categories. When you refer to a hybrid vehicle as a mild hybrid, the average power that is required from a battery system is not that much. It's only 5 kilowatts. The energy capacity of the battery is zero point 0.5. So this divided by this will provide the runtime for the battery, right? So the battery can run for about for 10 minutes because it provides this much power and the capacity is this much. As opposed to this, in a strong hybrid vehicle, the average power that is taken out of the battery or provided by the battery can be larger, 4 times as large as this, and the capacity and the size of the battery is also larger. This divided by this is 0.4 hours. So that provides the runtime of a strong hybrid vehicle. That means after this, it has to be recharged by some procedure. It can be regenerative braking or electric motor and so on. In an all electric vehicle, the average power can be this much, but the main point to notice is that it can be the same as this much, but the main thing is that the capacity of the battery is much larger or larger, not much larger, larger than the average power requirement. So this divided by this is 1.2 hours. That's the runtime. So during the operation of the battery, you have to recharge the battery in some particular manner. So a similar kind of category is provided here. What we are providing here are different classification of hybrid vehicles. In a stop and start hybrid vehicle, the battery provides power mainly for engine restart and electrical accessories. So the power requirement of electrical accessories is less, but the power requirement during restart is more. These two are provided by the batteries that is within the start and stop hybrid architecture. So the voltage of the battery can be small, it can be less than, let's say, 40 volts, and the power requirement is also lesser. When you implement regenerative braking along with this architecture, that is called a micro hybrid vehicle, the voltage of the battery increases and the capacity of the battery also increases. As opposed to this, a full hybrid system going from, let's say, mild to full hybrid system, what it involves is it has to provide the battery or rechargeable energy storage system has to provide power to accessories, engine restart that can be done, let's say, via a capacitor, regenerative braking is implemented. It also provides assistance in running the vehicle, launching the vehicle, accelerating the vehicle, running the vehicle. All these things fall under full hybrid vehicle category. The voltage of the regenerative energy storage system is greater and the capacity of the RESS is also greater. In all these cases, the regenerative energy storage system cannot be recharged externally. If you can recharge externally, that kind of a hybrid system is called a plug-in hybrid. Okay, so in the nighttime you may just use an electrical socket to recharge the regenerate rechargeable energy storage system, which may comprise of a battery as well as a capacitor. Such a provision to recharge the battery or the RESS is called a plug-in hybrid. In this case, the voltage of the RESS system is higher. It may have 300 volts, as well as the energy capacity can be quite significant. So here it's denoted as 15 kilowatt hour. In the last and final lecture in this series on electric vehicle, we will see how a fuel cell can be integrated into a hybrid electric vehicle. That's going to be the topic of the next lecture. Thank you.